Hello students, welcome to the lecture series of Engineering Mathematics 3 for the Dr. Batu Lonere engineering students. This is the first lecture of this video lecture series. Now today we will discuss first the syllabus and after that we will see the first chapter. Now the Engineering Mathematics 3, this particular subject includes 6 units. The first unit is Laplace transform, second unit is inverse Laplace transform, unit number 3 is Fourier transform, unit number 4 is partial differential equation and its application, unit number 6 is function of complex variable, that is differential calculus, and the unit number 6 is function of complex variable, integral calculus. Okay, so these are the different 6 chapters that we have to cover in this particular video lecture series. Now today we will start our first chapter, that is Laplace transform. So let us see this. So first of all we have to see what is meant by Laplace transform. So let us see the definition first. Definition of the Laplace transform. If f of t is a function of, if f of t is a function of t where t is greater than 0, that is positive, then Laplace transform of f of t is denoted by Laplace transform of f of t. Okay, so how to read this? This is Laplace transform of f of t, and it is given by Laplace transform of f of t is equal to integration from 0 to infinity e raised to minus st into f of t dt. Okay, so this is the general definition of the Laplace transform. That means if you have to find out the Laplace transform of any standard function, then by using this particular formula we can calculate the Laplace transform of that particular standard function. Now there are some basic rules or the notes. First note is Laplace transform of f of t is equal to f of s. Why this is so? Because as we have seen this definition, in this definition we on the right hand side there is integration from 0 to infinity e raised to minus st into f of t dt. So this f of t is variable. Okay, this we have to integrate this particular function with respect to t. So here constant is s. So if you solve this integration, your answer will be in the form of s, and that's why we can say that Laplace transform of f of t is always a function of s. Okay, now for solving some examples of the Laplace transform, there are some rules. So let us see these rules first. Rules of Laplace transform. So the first rule is Laplace transform of constant into f of t, that is k into f of t. If this is there, then what we can write here? We can take this particular constant outside. So k into Laplace transform of f of t we can write. Second, Laplace transform of f of t plus or minus g of t. That means if there are two functions or more than two functions which are in addition or subtraction, then what we can write? We can take this particular f of t and g of t common separately. So Laplace transform of f of t is separate, plus or minus. If there is a plus sign, then we can write on plus. If there is minus sign, we can write here minus sign, and here we can write Laplace transform of g of t. Okay, so in this way we can separate it. But remember, Laplace transform of f of t into Laplace transform of g of t is not equal to Laplace transform of f of t into Laplace transform of g of t. This is wrong. Okay, we cannot write this. Similarly, Laplace transform of f of t upon Laplace transform of g of t. This also cannot be written as Laplace transform of f of t divided by Laplace transform of g of t. This is wrong. Okay, so you have to remember these particular rules for solving the numericals. Okay, now after that, let us try to find out the Laplace transform of Laplace transform of some standard functions. Laplace transform of some standard functions. Okay, now let us see how to find Laplace transform of 1. Okay, so if suppose if f of t is equal to 1, then what is Laplace transform of 1, that we have to find out by using this particular formula. Okay, so let us do this. So here we can write this as, we know that Laplace transform of f of t is equal to, what is formula? Integration from 0 to infinity, okay, e raised to minus st into f of t dt, isn't it? So if you put the value of f of t is equal to 1, what we get here? Laplace transform of 1 is equal to integration from 0 to infinity e raised to minus st into value of f of t is 1, so into dt. So that is equal to, what is integration of e raised to minus st? E raised to minus st upon minus s, integration from 0 to infinity. Now if you simplify this further, what we get? If you put the upper limit here, what we get? E raised to minus infinity upon minus s, okay, minus of minus, that will be plus e raised to 0 upon s, okay, and that is equal to, what is value of e raised to minus infinity? The value of e raised to minus infinity is 0, so this term will become 0, and here e raised to 0 is 1, so that's why 1 upon s. So Laplace transform of 1 is equal to 1 by s. So this value you have got. So in this way we can calculate Laplace transform of other standard functions, okay, such as, now let us directly write down the formulas of standard functions. So here let us write down the heading, Laplace transform of some standard functions, okay. So first formula, just we have to remember these particular formulas, okay, for solving the numericals, okay. So first formula is Laplace transform of 1 is equal to 1 upon s, okay. Laplace transform of 1 is equal to 1 upon s. Second formula, Laplace transform of e raised to at is equal to 1 upon s minus a, okay. That means if there is positive a, then here in the right hand side the formula is 1 upon s minus a. Next, Laplace transform of e raised to minus at is equal to 1 upon s plus a, okay. Fourth, Laplace transform of sin at is equal to a upon s square plus a square, okay. Next formula number 5, Laplace transform of cos of at is equal to s upon s square plus a square. So what is difference between sin, Laplace transform of sin at and cos at? Here on the numerator there is a and here there is s, okay, that is the difference. Next formula number 6, Laplace transform of sin hyperbolic at is equal to what? Same formula of sin at, but only change is a upon s square minus a square. So in the denominator there is minus sign, okay. So this we have to remember. Next formula number 7, Laplace transform of cos hyperbolic at is equal to what? Same formula of cos at, but there is minus sign at the numerator. This is the difference, okay. Now formula number 8 is little bit different. Laplace transform of t raised to n is equal to, actually there are three formulas. So general formula is gamma n plus 1 upon s raised to n plus 1. Okay, this is for all types of n, for all n. Okay, for all n. But if suppose the value of n is positive integer, then for that we can write this as n factorial upon s raised to n plus 1 if n is positive integer. Positive integer means what? Positive integers. What is my positive integer? 1, 2, 3 up to infinity. This is called positive integer. Okay, and for what? Next formula in the same, okay, that is equal to n gamma n upon s raised to n plus 1 if n is in fraction. Okay, n is in fraction. So what is my in fraction? 1 by 2, 4 by 5, okay, 7 by 2, like this. So this is fraction. Okay, so just we have to remember here one formula, gamma n plus 1 is equal to n gamma n, okay, or it is equal to n factorial. Okay, this is the formula that we have got. When we have to use this formula? For fraction, and this formula is for integer, positive integer. Okay, remember this, positive integer. Again here we have to remember one formula, gamma 1 by 2 is equal to what? Root pi. The value of gamma 1 by 2 is root pi. Okay, now how to implement these particular formulas for solving the numericals, that we will see one by one. Now let us try to solve some examples on this particular formulas. Okay, so let us try to find out this. Just 1 second. So type number 1, examples based on basic formulas. Okay, whatever we have covered in, okay, Laplace transform, some standard functions. So depending on that, and whatever basic formulas are there in the mathematics, so depending on that we have to solve some numericals. So let us write down first example. So example number 1 is, find Laplace transform of t raised to 3 by 2 plus t square plus e raised to minus 2t. So if you have to solve this example, how to solve this example? This is very easy example. So that is equal to, by using rule number 1, we can separate these particular values. So Laplace transform of t raised to 3 by 2 plus Laplace transform of t square plus Laplace transform of e raised to minus 2t, isn't it? So that is equal to, by using formula number 8, okay, just we have studied that formula. So here, so Laplace transform of t raised to n, if n is in fraction, so this n is particular in fraction. So for that, which is the formula? N gamma n upon s raised to n plus 1. So by using this formula, how you can write this? So this can be written as 3 by 2 gamma 3 by 2 divided by s raised to 3 by 2 plus 1. Okay, plus here, what is formula for this? This is positive integer. So what is the formula for positive integer? 2 factorial upon s raised to n plus 1, that is 2 plus 1. So here we have tried 2 plus 1 plus. What about this? Laplace transform of e raised to minus 2t. How you can write this? So that is equal to 1 upon s plus 2, because here it is negative. So इसका opposite आपका क्या रहेगा? Positive. So that's why answer is 1 upon s plus 2. Now if you further simplify this, how to simplify this? So 3 by 2 as it is, gamma, this gamma 3 by 2 can be written as 1 by 2 plus 1, okay, divided by s raised to 5 by 2 plus 2 factorial is 2, s raised to 3 plus 1 upon s plus 2. Again this can be written as 3 by 2 into, what is gamma n by 2, gamma n plus 1? So the formula for this is n gamma n, so that is again 1 by 2 gamma 1 by 2 divided by s raised to 5 by 2 plus 2 upon s raised to 3 plus 1 upon s plus 2, and this can be finally written as 3 ones are 3, 2 2s are 4, and gamma 1 by 2 is root pi. So that is root pi divided by s raised to 5 by 2 plus this is 2 upon s raised to 3 plus 1 upon s plus 2, and this is value of f of s. This is the answer to the given question. Okay, so I hope you understand this particular questions. Thank you very much. Now let us in lecture number 2 we will start from this particular example number 2. Thank you.